Hey guys, welcome to today's lesson. Today we're gonna start 8.3, estimating the population mean. So just like how we're estimating the population proportion, our first lesson I will give you the formula for calculating the confidence interval, and then we're gonna talk about how to check condition. And one other important thing in this video, I will introduce another table for you, which is the t-table. Before we get started, please go to Google Classroom, pull up the PowerPoint and the notepad so you can see what I'm doing. All right? So let's get started. So after today's lesson, you should be able to do the first two goals for our lesson. Determine the critical value for calculating a C confidence interval for a population mean using a table of technology. You need to know how to find the critical value. For the population proportion, the critical value we find is Z star, right? And in this lesson, we're gonna tell you what is the critical value and how to check table for that. And number two, state and check the random 10% and large sample conditions for constructing a confidence interval for a population mean. So mean is very similar to proportion. We're gonna check for condition, but the details will be slightly different. We will show you some example and talk about how to do that. So first of all, let's look at the formula. The formula is x bar, which is your sample mean, plus or minus your critical value. This time is not Z star anymore, it's T star. And over standard deviation over square root of n. So this formula is very similar to what we have in proportion. Again, it's the point estimate plus or minus of margin of error, but the details, look, our critical value is different, and over here the standard deviation is different. And this standard deviation formula is from the standard deviation of population mean. If you don't remember, please refer the videos in chapter 7. And they said where the T star is the critical value for the T distribution with n-1 degrees of freedom. So over here we have another definition, degree of freedom. So it's actually, this is very easy to use. Degree of freedom is just your sample size minus 1. If I have my sample size as 5, my degree of freedom will be 5 minus 1 is 4. It's just that simple. And the C percent of the error between negative T star and T star. So how to find T star in a little bit, I will introduce to you. And over here, we will not get into the detail of what's the different, like how the inference is different between the T table and Z table. If you are interested in that, please comment and I will make another video for just that. Okay. All right, how to find the T value? So T value, as you can see from the T table, okay, I will pull it up. It's also on your Google Classroom. Okay, T table looks like this. Ooh. All right, you need a upper tail probability P. Again, if you can see your T is over here, and the probability we want to find is the one side of the P. It's the same thing of Z value, okay? And then we need a degree of freedom. So first of all, you need to find a degree of freedom. Okay, let me put that in the board so it's easier for you to see exactly what's going on. So, okay, let me read the question. So we want to find the critical value for confidence level. Confidence level is 99%, okay? And the sample size n is 4. Okay, if you want to find that, the first step, you want to find the degree of freedom. Degree of freedom over here is just n-1, which is 4 minus 1 is 3. We have degree of freedom is 3 here. And the next thing we want to find is exactly like what we did in normal distribution. We want to find if the inside we want is 99%. if I have a negative t star and a t star over here, we want to see each side is how much. So we use 1 minus 99%. We know both of them add together is 1%. And each of them will be 0.5%, which is 0.005. Okay, so we will use our degree freedom of 3. And then the percentage with is the area of my upper tail to determine what is this t star. Okay, so let me show you how to find that. So on the t table, you first of all you need to find the degree of freedom is 3. So over here 3 is this line. Okay, and this line degree freedom of 3, and then your upper tail probability, which is your area above t star, is 0.05 over here. So 0.053, your number is 5.841. Okay, it's this number, 5.841. All right, so this is how you find the t value. You find the degree of freedom, and then find tail probability and check your table. All right, let's look at this question. So since you have it pulled up on your screen already, so I will just read the question very quick for you, and then I will exit the screen and we will do it on the board. If you do not have your PowerPoint pull up, you can take a picture or pause the video and think about it before you go on. So they ask you what is the critical value from table B, which is our t table, should be used in constructing a confidence interval for the population mean in each of the following settings. The setting number A is 95 confidence interval based on a sample SRS of sample size n equals to 12. Second one is 90% confidence interval from a random sample of 48 observations. Okay, all right, let's go ahead and do that. All right, so I will copy down the example over here. Let me erase the old one. So this one, A, we have confidence level is 95%, and our sample size n is 12. Okay, so first of all, we want to find the degree of freedom. Degree of freedom is 12 minus 1 equals to 11. Okay, and then we want to find the probability of upper tail, and I will do it for this one, but like if you have a very good mental math skill, you do not need to do this every time, okay? I'm doing it on the board, it's just because in case you missed last time when we do this kind of problem. Right, okay, this is the wrong calculation. Inside is 95%, and then each side will be 2.5%, which is 0.025. So we want to use the degree freedom of 11 and 0.025 as our probability. Okay, and then you're gonna check the table, and you will find 0.025, which is here, and you go down to degree freedom of 11, you have your number 2.201. Your T star is critical value is 2.2, what I just said? 2.201. Okay. All right, so this is for A. Okay, so for B, it's the same thing. And you need to be saying our critical level is 90%, and the sample size n is 48. Okay, and again, you're gonna find the degree of freedom, which is 48 minus 1 is 47, And then you're gonna find the probability. Again, you're gonna use 1 minus 90%, which is 10%, break it to 2 tails, which is 5% each. So 5%, 0.05. So we want to find 47 and 0.05. If you actually try to do it yourself, you will see a little bit problem because 47 is not in our table. So let's find 0.05, which is over here, okay? And you're gonna go down to 47. Okay, this column go down to 47. They do not have a 47, but they have a 40 and a 50. So here is the question, which we want to use? We want to use the 40 or the 50. So over here, we always want to use 40. We want to make sure the confidence interval we get can cover every possible data we get. We do not want to like make it so narrow, which we cannot say we are 90% sure of blah blah blah. So we want to choose the bigger number. So over here, if you look at the Z table, if you want to find the bigger number, it's always gonna be look for the sample size smaller than what you're looking for. So for example, if we have 47 here, we want to look at 40. Since 40 have a bigger T star value. I don't know if that makes sense for you, but just make sure you know that if you cannot find your degree of freedom in the table, you always want to go by a lower degree of freedom, which since we had 47, but you cannot find it, we go for 40. So 1.084 is our answer. So over here, our T star is 1.0684. I don't remember what I just said. 684. Okay, so over here, that is the T star we want to find. So this is example 1. It's not very hard. It's just showing you how to find your critical value T star. All right. So again, like everything you can check on table, we always tell you can use calculator. And but again, like if you don't have a calculator, don't worry about it. Table works just as well. Okay. So I want to so how to use calculator to calculate it. Let's do the calculator for both of them so I can like show you better. If you are on the PowerPoint, we're on page 7. So calculator, they said you're gonna press 2 second vars and go to distribution. Let me see if this works. I saw a lot of people do this. You know what? Doesn't work. All right, second vars, you're gonna do second vars. You're gonna pull up a screen and they have distribution, and Joe, you wanna just go to the distribution and go down to interval INVT. Okay. All right. And then the first number you're gonna input is your area. It's the over here is the 0.025 we find. 25. And the second number you're gonna put is your degree of freedom is 11. So after you get it, you hit enter, you will have negative 2.2001. 0.00098 actually. So if you get rid of this negative, and over here will be your answer. Okay, let me see. Okay, does not work. I can make it work, but is that necessary though? Alright, not work at all. So let's try the second one. Second one, again, you're gonna go second vars, and then you're gonna go down to INVT, interval T, and then inverse T. I think it's inverse. Okay, I just saying random stuff. All right, T, and then you're gonna go. You're gonna find your area 0.05, and then you're gonna go to your degree of freedom 47. Hit enter. you will have negative 1.6779, which is very close to this answer. Again, if when we use the t-table, it's not very accurate because it's for distribution, it's always when we talk about the normal, it's continuous, but they don't have every value in the table. So what we get is the value that's close enough. Okay, so both of them will be count as correct in the test. Okay, so this is how you use the calculator to find. This is how you use the calculator to find confidence. Okay, this is even worse. This is how you use the value to find critical value. I don't even know what I'm talking about now. All right, let's try another one. So this one, let's use both of the method. So let me read the question for you. We want to use table B or calculator, whichever you're comfortable with, to find the 96 confidence interval based on the random sample of 22 and 99% confidence interval from SRS of 71. This question is exactly like the last one, and let's just go over it very quick. It won't take very long, so let's do that. Alright, I know I should not like. Okay, is that clear enough for you? Okay. So example 2, number 1, they ask you to find a 96%. Let's just erase all of them. So confidence, they want to find a 96%, confidence level is 96%, and then the sample size is 22. Okay, over here we want to find the degree of freedom. 22 minus 1 is 21, and then your percentage, 1 minus 96% is 4% divided by 2%, 0.02. Okay, 21, 0.02. When you check your table, all right, let's get my face out of here. Let's look at the table. So 0.02 over here, and then you go to 21, 0.02, 21. Got it. 2.189. 2.189. Okay, what am I doing? All right, 2.189. Okay, and use calculator, you will have interval t 0.02 and degree freedom 21. So if you use calculator, again, you're gonna go to second vars. Second vars, and you go to INVT at 0.02 and 21. You got the same answer, 2.189. Okay, and B will we will do the same thing, and confidence level is 99%, and confidence and sample size is 71. So degree of freedom is 71 minus 1, which is 70, and then your percentage you want to use 1 minus 99, 1% divided by 2, 0.5%. Okay, so we want to find 0.005 and 70. So 70 is pretty big number. I will think maybe it will not be in our table. We will check it out. I'm not sure neither. So let's look at it here. 0.05 is over here, and we're gonna go down to 70. See how smart your teacher is? It's now here. Alright, I'm not very smart. Okay, I'm gonna just stop here. So we're gonna check 60, so it's 2.660. T is 2.660. If I make any mistake, please let me know in the comments, okay? Okay, and if you want a more accurate answer, you can use calculator. Interval t 0.005, and 70. Okay, let's do second verse and ANVT 0.005 and 70. You have 2.648. Again, very close to each other, but they are not the same answer, since over here we check the degree of freedom we use is 60 instead of 70. Okay, so over here is how to find the critical value of t. So I hope you get what's going on here, and it's very similar to checking the z table, but over here we use another component. It's called degree of freedom, which is n-1. Right? So let's keep going. So after we find out how to check the critical value, we also want to learn how to verify the condition has met. So the condition is very similar to the proportion. First of all, we want to check random. And random, we just need to see in the question if they said it's from a random sample or randomly selected, or that is the SRS. If they have that in the question, we can see, okay, that is randomly selected. Number two, we want to check for 10%. 10% is for checking independent. Basically, we want to see our sample size if it's less than 10% of the population. If the population is really big, and we can assume it's less than 10%, for example, if we said, I want to randomly selected 500 boys in the United States, even though they didn't tell you the boys' population in the United States, you can assume it's less than 10% because all the boys in the United States definitely are more than 5,000. And then the last one, we want to check the large, like in the proportion is called large count condition. Over here, we just want to charge if it's a large sample. And we can also call it to check normal, because no matter it's a large count condition or large sample, eventually we want to see the distribution for mean is normal. So there are two ways to check normal. Number one, we can say it's the population has a normal distribution, or the sample size. The first one is the population has a normal distribution. We said if the population has a normal distribution, then your then your population mean also have a normal distribution. So the first way we can see is we just actually gonna lay out all the data in a histogram or a dot plot, and to verify the shape is normal. Actually, over here, it is normal. It's not really strictly it is normal. It's just saying they do not have a significant skewness. It's not skewed to the left, skewed to the right, as you can see. And also, they do not have very significant outliers. And or if the distribution is not normal, you can see they have a skewness, but the sample size is large enough, it's greater or equal to 30, we can say the distribution of population mean is approximately normal. Okay, so distribution of sampling distribution of mean is approximately normal. So there are two ways. Number one is the original population is a normal distribution, also saying it's not like strong, don't have a strongly skewness, do not have a very significant outlier, or the sample size is larger than is greater than 30. Okay, right now we're gonna see 3 examples and actually see what do I mean. All right, let's look at example 3a. So basically, we want to check condition for this situation. In this situation, you have randomly it is randomly selected, and it's 50 students, and here is a histogram. So I will use my notepad for this session, so I do not need to write all the words down. Give me a second, let me rearrange my screen. All right. Okay. So I have question pull up on the left, and I will use the right to do that. So I want to see example 3 here. I want to check condition for A. So for check condition, first one, we want to see if it's random. Random, you want to read the question and to determine. So they said to estimate the average GPA of students at your school, you randomly select 50 students. So that is check. Randomly select, you will say, this is randomly select 50 students. Okay, let me double check my screen. Okay, still working. So over here, check. Okay, and second one, you want to do 10% condition to verify independent. Okay, 10% condition, n equals to 50 is less than 10% of the population. What is the population here? Is all the school students, all the students of your school. Okay, so if you think about 10% is less than 50 is less than 10%, which means your population at the school have to be more than 500, which is reasonable. Okay, and especially they said, yeah, in a school they will have more than 500 students. So you can assume that. And then over here we have another check. Okay. And next one we want to check for normal. Normal, there are two ways to check it. Number one, you will see, okay, the population is approximately normal. Actually, in this graph, it is kind of approximate normal. You can use that, or you can use the large number. So you can see n is 50 is actually greater or equals to 30. Okay, so over here, if your sample size is large enough, you can say it's approximately normal. So over here, good, check. So your conclusion for this this question will be yes, it meets all the conditions. So that is for A. Okay. All right. Let's see B and C. So B again, you're gonna do random, and you're gonna ask yourself in the question, do they mention random? They actually did, because they said 20 randomly selected pieces. Okay, so this one check, no problem. Number two, 10% condition. Okay, and you will say they randomly selected 20 pieces. You want to think about like, is all the wood pieces greater than 200? And you will think yes, because they, of course, they will have like more than 200 parts. So you will say n, or you can start with assume n equals to 20 is less than 10% of all the wood pieces. Is that wood? Yep. Okay, so this one check, no problem. And the next one, you're gonna see normal. Okay, do not check anything until you for sure you know it can be checked. So normal, we said if it's less or greater or equal to 30, it's approximately normal, no problem. But over here, our n is actually less than 30, so it's 20. So our n equals to 20 is not less than, it's not greater or equal to 30. So you cannot use approximate normal. And so you can see, you have to try to look at the population and see if the population is approximately normal or not. And over here, you can see this is a steam plot. And this steam plot, is that normal? It's not really. If you look at here, it's skewed to the left, right? And you will say the population distribution is strongly skewed to the left. So it is not normal. Okay, so over here, this normal condition does not meet. So over here, you should say no, because we cannot assume the distribution is normal. It's normal. So for this situation, you cannot use your formula to calculate the confidence interval because the normal part does not meet. Let's look at the last one. Okay. So hopefully after this 3, you will know exactly how to confirm condition. Random. So this one, random, they said for a random sample of 20 students. So that's good. A random sample. So as you can see, all 3 questions, they use the word random, but they express it differently. So you need to read your question carefully and make sure in the question they have the information of random. Okay, and then 10%. They select 20 students. So we can assume n equals to 20 is less than 10% of all students who took SAT math in the school. Okay, and over here the 10% condition, you need to make sure it makes sense. If they saying, okay, they select 200 people or even 2,000 people, you cannot assume that, because we are not sure if people in school will be more than 20,000. That's not possible. So over here we can only make the reasonable assumption. Okay, and the last one, normal. Okay, so this one n again equals to 20 is less than 30, so you cannot assume, and we have to go to the population. Look at this box plot. So I understand a lot of you guys say, okay, this box plot is skewed to the right because this tail is a little longer, but if you look at the main part, there are 50% of the data is over here, and this is our quartile 3, is our median. So if you look at here, most of the data, they are pretty symmetric, pretty normal. Probably only have a little bit of data over here showing the shape. So over here, this is kind of a moderately skewed to the right. It's not very strongly skewed to the right. So over here, since they don't have the strong skewness or outlier in this box plot, they do not have any outlier. Remember we said if we have outlier, we'll have stars. On the right over here, we'll probably have stars here and there, but this one do not have any outliers. So over here, since they do not have strong skewness and significant outliers, so we can assume normal. Okay, so over here, this one is checked. Again, when we check for normal, it's not need to be strictly normal. It's just need to be approximately normal, as long as they don't have very strong, the population don't have very strong skewness, don't have very significant outliers. We can check that. So over here you will say yes, it met all the conditions. Okay. All right. So this is example 3. And the notes you can also find in the Google Classroom. Alright, so in today's lesson, give you a quick summary. We learned the formula for finding confidence interval. Tomorrow we're gonna bring it back to talk about it. We talk about how to find the critical value. Over here for population mean, we are using the T star instead of Z star. And then we learn how to check condition. Those steps take place in front of you do anything with the formula. You have to check the condition to see if they meet all 3 conditions, which are random, 10%, and also check for normal. If they are met all the conditions, you can calculate your confidence interval with your formula. And in tomorrow's lesson, we're gonna talk about how you're gonna construct and interpret a confidence interval for population mean, which is we're also gonna repeat our 4-step process. So we will have a good time there. Okay, so I will explain to you what to do in the Zoom meeting in a little bit, and I hope you enjoyed today's lesson. I will see you next time. Bye bye.